Well, the Quadrantids meteor shower is an annual shower of meteors, and meteors are basically the result of small pieces of debris coming into the Earth's atmosphere at high speed. And by small, I mean anything from grains of sand up to marble size. Not very big at all, but they come in so fast, up to 70 kilometers each second, many times the speed of a bullet, that they heat the atmosphere around them, and that hot air glows. And that's what we see as a shooting star or a meteor. And typically they only last a fraction of a second. If you're very lucky, you might see them lasting longer than that. But normally they're very, very fleeting. Showers happen because the Earth runs into a stream of debris rather than just random bits that are coming in all over the sky. And that's what the Quadrantids is. It's a shower that happens more or less at the same time every year. It's associated with a particular part in the sky, and that's because the Earth is running into a particular stream of debris. Now, the name comes from the fact that it's associated with the now defunct constellation Quadrans Muralis, which basically means a quadrant that was mounted on a wall. And this was a constellation that was created, as many were in the 17th and 18th centuries, but it wasn't adopted in the present day. It's actually in the part of the sky between Ursa Major, which includes the Plough, if you're familiar with that in the UK, and the constellation of Boötes, the herdsman. So it's in that region of the sky, not far from the pole star. The Quadrantids are unusual in that they appear to be associated not necessarily with a comet, or maybe an extinct one, but with an asteroid called 2003 EH1, which means it was discovered in 2003. Now, it passes reasonably near the Earth. It's called a near-Earth object, and we appear to be running into a trail of debris associated with it. So the thinking is that might actually be an extinct comet, so no longer anything generating a tail. Doesn't look like a comet these days, just looks like a dot on even images from the largest telescopes. But 500 years ago, there was a comet seen back in 1490, more than 500 years ago. There was a comet seen by the Chinese, and it may be connected with that. So it may be that this comet was once active, has left a lot of debris in an orbit around the solar system, which the Earth runs into once a year, and that leads to the Quadrantid meteors. This year, the shower is forecast to peak at 3 p.m. UK time, so 3 o'clock GMT, on the 3rd of January. Now, that means that if you're, say, in the Pacific or on the western coast of the US, you're pretty much in the prime place to see it, because for you it'll be in the small hours of the morning. In the UK, obviously it'll still be daylight, but if you wait either into the evening after that, so on the 3rd, or you can, if you want to get up early, you can look on the morning of the 3rd as well, or you can wait further into the night and look at the, say, the morning of the 4th. All of those times are reasonable times to spot it. The only caveat is that it is quite sharply peaked. So the shower itself has a really sharp peak over a few hours, which means the rates will be a bit lower. However, that said, it runs over a couple of weeks, so it's well worth looking the night before, the morning before, the evening after, and the morning after that to get a chance of seeing some meteors. Well, the Quadrantids are not bad as meteor showers go. They have a pretty strong intensity if you happen to be in the right place at the right time. So if you are on the west coast of the US and the Pacific region, you could see maybe 70 or 80 an hour. If you're in the UK, you're going to see somewhat fewer than that, or at least it's likely that's the case. But it's still a strong shower. The great advantage this year is that the moon isn't interfering with it, so you haven't got a full moon in the sky. It's a very thin crescent. That means the light from the moon will not be a big problem. And if you get out to the city, into a dark place, away from sources of light pollution, then you have a chance maybe of seeing up to a few tens of meteors an hour, maybe realistically perhaps 20 to 25. They won't be the brightest meteors on the whole, but it does include a fair number of fireballs, quite typically. A fireball is a dramatic sounding thing. What it really means is a really bright meteor. And the Quadrantids is a meteor shower that produces that kind of event. So for that reason alone, if you have the time to look out and the weather is good, then do take a look. It's a perfect New Year treat. The really nice thing about a meteor shower is that you don't need any special equipment. You just basically need to have half-decent eyesight. If you have a telescope or binoculars and you try to watch a meteor shower, you're going to make it harder because you'll only be seeing a tiny part of the sky. What you need to do is go out, wrap up well, because it's January, it's going to be a bit cold, So take a flask of tea, put a lot of layers on. Be prepared to wait outside for a bit and just watch the sky. Now the radiant, the part of the sky that these meteors appear to come from is in the start of the night. It's over in the north, in the northeast. It swings round towards the south as the night goes on. But really, they could be anywhere in the sky. So the best piece of advice that I would give is just to look up, look at the sky, get an uncluttered view, be away from the lights of towns and cities, and see what you see. But do be patient. Don't go outside, and if you don't see one in the first 5 minutes, be disappointed. I think the thing to do is to give it maybe half an hour or so. And you'd be very surprised if you didn't see any at that time. Photographing meteor showers requires patience. If you take your mobile phone camera up and you just click at the sky, you're unlikely to capture anything because they're so fleeting. They only last perhaps a fraction of a second. That your reactions are not going to be good enough to photograph it. So what people tend to do that are used to photographing is they do what are called long exposures. So they open up the lens, the shutter, or the electronic shutter, depending on how you define it, but say something like a phone, and leave it running actually for as long, at least in total, as a period of minutes, anything up to half an hour. In some cases, people have all sky cameras that run all night. And you have to do that because you never know exactly when the meteor is coming. And so you need a long period of time to see them. If you do it well, and I guess people with DSLRs that can run for hours are the best place to do this. That's another option, just a more sophisticated digital camera. What you'll see is star trails. These are the result of the Earth turning, and then the stars appear to trail across the sky as they appear to move. And then superimposed on that, you'll see streaks of light, bright streaks, and those are the meteors. Those will be the Quadrantids. So it's not as simple as, say, holding up your camera and taking a picture of the northern lights. My advice would be to read up on it beforehand. Don't try and do it on the night because I think it'll be a struggle. But if you've got the right kind of setup, a decent tripod, an ability to open up your camera for a long period of time, then you should see something.